Yo, welcome back to Finnegan's Garage. Thanks for hanging out. And more importantly, thank you for visiting fsmgarage.com to get all your new merch. Hats, stickers, hoodies, even though it's summertime, all that stuff. Very special episode. Cletus McFarland is in the house. We're making huge progress on my wife's jet boat, and we set a new personal best in terms of speed, but not without struggling. Check it out. Upgrade time. This is the elbow that we made to connect our two Nelson mirror image turbos to our Motion Raceworks Icon throttle body. It was a compromise. It was built using what we had laying around to get us on the water for the family vacation. Now we're going to go back and redo it. The reason we're going to redo it is each turbo has a 2.5-inch outlet that merged into a 2.5-inch outlet, which is a restriction. And that restriction continued from here to here. And I was having problems with my TIG welder that day also, or my TIG welding. And so this is a restriction, and I'd like to improve the welding. So we're gonna cut it back here. So it's a 2.5, 2.5 welded together to a 3-inch. And then we're gonna go 3 to 4-inch right here with some pie cuts. So that should increase flow, maybe reduce temperatures, maybe, not sure. Not sure if that'll help the air inlet temps into the engine or not, but we're gonna do it. So right now, cut that off, cut that off, cut that off, start again. This is the fine Slugger 14-inch cold saw. And I've had this thing for about probably 6 years now. I paid a little over $500 for it, and it is a workhorse. It goes through everything: aluminum, stainless, regular old steel. It does thin wall, exhaust tubing, and the key to it is low RPM, and it's not an abrasive blade. It's got teeth. And this one here, although it looks okay, it's about on its last leg, so we're going to change it before we go cut up some thin aluminum tubing. Because when this is right, it cuts perfect, like it's going through just butter, and it doesn't leave any slag at all, and it's fantastic. But this blade is worn out to the point where it will deform the aluminum tubing if I tried to cut it real quick, so I'm going to put a new one on there, and then we'll get back to work. All right, the internet says our 2.5 merge is causing a restriction. So we could have gone 3, we could have gone 3.5. Let's try 4.
Yeah, we hear your complaints, and we see.
Keep squishing.
Oh boy. We see a solution. You just tell me when to stop.
And stop. It's right there. It springs back quite a bit.
I like it because it's closing up where it's supposed to. Hey.
Yeah, man.
A little more?
Yeah, you could go a little more.
All right.
Ooh, okay. That's pretty close. Whoops. I got a little more. I got a little too much.
Where's your glasses?
You were the one working it.
You're the one controlling me.
Oh.
All right. We'll fix this. We'll fix this.
Just need to expand it a little bit.
Yeah.
So here's what we're doing. We're going to show you guys how to make pie cuts the easy way. And step number one is to find the center line of whatever tubing you're using. So this is 4-inch aluminum tubing. It's got an 0.67 wall thickness. We are going to use this piece of aluminum scrap, and we are going to take our Sharpie, put it on top of the aluminum scrap, and when you do that, that puts the Sharpie at exactly 2 inches high off the table. So if I tape my Sharpie to this aluminum scrap and I run the Sharpie down this side of the tube and Dave doesn't move it, and then I run it down the other side of the tube, we know we have marked the exact center line of our tubing. And as long as that line stays there, when we cut this at pi, and we have all these cool angles, and we go to weld them together, as long as we line up the center marks, we know this is all correct and it's going to work. And if we cut this at 9 degrees on each side of each pie cut, if you take 5 of those pieces, that adds up to 90 degrees. That's basically what we're trying to achieve here, is a 90-degree transition from here to here, from our turbos to our throttle body.
Yeah.
Yep. Take the Sharpie, set it on the table. That is exactly 2 inches. It was meant to be. So we've taped our Sharpie to our scrap, 2 inches off the table. And now we mark it. As long as your table is flat, this works.
There's a lot of dents and dings and weld splatter on there, but
Yeah.
you get the idea.
In general, it should be all right. I went about this far, about a foot. So now, what Dave's gonna do, go over to our saw, set our saw angle at 9 degrees. He's going to cut the tube off here on one side, then he's going to flip it over and do 9 degrees going the other direction, and that will make a pie cut. If he does 5 of these, every one of those will have 18 total degrees of angle, and you add them all together, that makes a 90-degree angle that you can twist and move and do all kinds of crazy things with. Then we can take our 90-degree where the pie cuts over to the boat and see, do we have any chance of fitting a 4-inch tube in a space where before we only had a 2.5-inch transition here. This is what it looked like before, right? We have to get from here to here somehow with a 4-inch tube. I don't think it's going to work, but we're just going to try it to see what happens. And then probably what we're going to end up with is a 3-inch tube, realistically, but we'll try. All right.
Yeah.
Yeah. All right, Dave just cut our first angle on here of 9 degrees. Now he's going to rotate the tube over, cut the other side at 9 degrees, going the opposite angle, and we're going to move these as close together as we can because we don't have a lot of room to work with. What do you think, 1/4 inch apart?
That's what those were. And you can see the spacing was about 1 inch from when it started to where it ended. So,
Wow, on 4-inch tube, it's probably going to be like 1.5 inches.
well, I mean,
Let's find
but
out.
you got to have some material there to weld to. Like, you can't have it like
Yeah.
in the bend like that.
Yeah.
That
All right,
thin,
try it,
so-
1/4 inch. Give it a shot.
All right, I need another fine tip Sharpie.
There you go.
I got it.
It still works. It's good. You said my Sharpie's not good enough. I'll get you one. I'll get you one. Got some fame. So the reason we drew that center line is so that when he rotates the tube, you know he's cutting parallel to the other side. He'll get his ruler out, he'll make sure we're 2 inches off the deck to that line, and then he can go ahead and cut. So a little more than 1/4, but whatever. It's a start. It's about 3/8.
Okay.
So do that again. More times.
There's 4. We just need 1 more, supposedly, to make our 90. Dude, this is pretty tight. This may actually work. Look at that. That's a pretty tight bend.
Yep. Huh. All right, let's do 1 more and find out.
What's this?
You're only replacing this with that. Whoa.
Dude, look.
That might actually work, dude.
I'm gonna cut a couple more. We'll cut 1 more of these, but it is like this one's a little thicker here, but we may have some options to like.
Yeah, because it may not be exactly 90 in the boat.
Yeah, so we'll cut 1 more of those, and maybe just a couple more oddballs just to.
I'll fire up the TIG welder. Stack some stuff together.
Sweet. Let's clean it, but don't take our marks away.
Yeah, I'll let you do that.
You ready? Mm-hmm. All right.
Mm-hmm.
It worked.
And I'm gonna let go.
Okay.
Rotate it. Push this together on this side. So here's the result, right? This is what we had before, 2.5 inch tubing, merging up to 3, 3.5, then 4. This goes into the elbow for the throttle body. This goes into our Y out of our 2 turbos. We just made this out of a piece of 4-inch tubing, pie cut, and it's no longer,
So big.
it's no longer than the 2.5 was, but you no longer have this choke point anymore. We have a smooth, perfectly round transition. And now what we have to do is neck this down to fit our Y.
Which we're going to use, I think, this guy right here, right? Somewhat. We're going to maybe cut this guy somewhere out here.
Yeah, this will probably go here and get cut
Yep.
maybe here and then squished. We can set this up in there and go, all right, here's our distance from here to here, and go, it has to be cut there, it has to be squashed there.
So I think we need to cut our Y, our merge.
Yeah,
Cut it back as far as we can. And then that way it'll only make it easier on us out here.
So here is what this used to look like, right? And now what we're gonna do is we've cut that out. This is still 2.5, 2.5. We've cut it here, shortened it. This is about 3 inches. We're gonna cut it back further to this line, which will make it about 3.5. And then we are going to merge, probably cut this right about here and merge that piece to that piece there, eliminating the choke point that we had here. This transition right here, which is only about 2 inches long. But basically you're taking 2 turbos, each with a 2.5 inch outlet, and sticking it into one 2.5 inch tube from here to here. So this was a choke point. What we're wondering is this making the air hotter than it needs to be? And also, is it a huge restriction? So this will be the only change we make to the boat. We're gonna change this area here, go out and run the boat again, see if it runs better, see if our air inlet temps go down. Just science it.
Yeah.
Learn what we can. All right, so let's cut this back to the 3.5 line, and then we'll put it back in the boat, figure out how much of this we have to cut off to get this to mate up to the throttle body again. Straighten it out.
I'm worried your fingers are going to get smashed.
I hope not. Dude, it's way better. And now do the corners.
Dang.
Let me lean across the table. Get out of the line of fire here.
Slips.
Okay.
Oh boy. It's a good thing you're wearing that rubber wind ring. Here's a straight round 2.5. We can compare that. Then we can find a 3. Here's a 3.
All right, so we're bigger than 2.5.
That's good. Here's a 3.
We're not quite to 3. We're beating.
There's an easier way. We need like a cone. Some type of cone to just drive in here to.
Oh yeah.
What do we? There has to be an easier way.
And like this?
Just, I wonder how bad that would damage the.
It's got to work, right?
No, it's already hitting the inside.
Well, you got to cut it off. We're not using that anyway. I'll just cut it off and keep smacking it down on there. It'll flare it out. Good. We put the wooden handle here. I like this. Let's do that. It's not working. That is beefy.
Yeah, there's no doubt that it has flow now, right?
Oh yeah. Yeah, that's gonna fit good. That'll be pretty easy to weld too.
Yeah. So what I want to do in the morning or whenever, I want to put a tack, like I want to put like a tack there, pull it off. Like the bottom is butted up to it, but we can massage this. We actually need to tap this in on the bottom, and it'll actually countersink into here a little more.
Okay.
I think it'll weld better, but dude, it's there.
And we need to cut off the mount for the blow-off valve from the old tube.
Yeah.
And the throttle mount. Which throttle mount, I think we'll be able to shorten it a little bit. Not
A lot.
Too big. Yeah.
About an inch.
Cut it in half.
Yeah.
Nice.
This fits a lot better too. There's no gap. It ain't sitting funny, like it's sitting flush.
Okay, everybody. Here is the original elbow, which where's the transition from the turbos? So this is what it used to look like, right? It's 2.5 OD there, 2.5 OD there, coming together in a 2.5 OD pipe because that's what we had. And the internet, as well as several reputable engine builders, believe that's a huge restriction there. And I don't know the answer, so we're gonna find out. So Newbern and I made this, which 2.5 into 4, no restriction there, I don't believe. And the fit.
There's the perspective.
Yeah. All right, the fit up is really good. And so we're gonna throw some tacks on this, throw it back in the boat, make sure it fits before we final weld it. And then we're gonna cut off our wastegate mount from here and our throttle cable mount from there, put those back on there, and then go testing.
Yeah.
Look who we got in the driveway today. That's right. The giraffe himself is here. We're going jet boating again. Wifey's boat. Almost ready to go.
We're gonna go fast.
Yeah, Garrett is putting the blow-off valve back on. We did make a new intake elbow. However, our air inlet temp sensor never arrived, so we can't really find out whether we have really hot air or not coming out of our turbos. But it doesn't matter. We can go out there and see if she goes any faster with the new elbow. I don't think she's going to, but if she does,
intake air temp is really just a number.
Yeah, you decide whether you like the number or not.
You decide. You know, that's why I don't run those sensors on my car. You know, it's best not to know.
No data. It's just telling you stuff you didn't want to know about anyway.
Exactly. I've never looked at my intake air temp sensor and been like, wow, that's good. You know, so I just decided to opt to not even have one.
Man, that thing looks so freaking good, dude.
Ooh, that's no bueno. Whoop. Did it hit a boost cut?
I don't know. I'll pull it over to the sand and we'll plug into it. It's never done that before. It's never done that before. I might never have hit it that hard either, but it's never done that.
It did it out there too.
Yeah. Well, let's plug into it. And it feels like it's hitting a boost cut or a rev limiter or something, but it shouldn't be making boost that fast, like right out of the hole. It usually takes 2 seconds from the time you hole shot it till you have full boost. So I'm not. Yeah. Okay.
I wonder if this was a result as the different elbow, like the different.
You think?
The amount of air that's.
Yeah, could it flow that much more air or now all of a sudden the fuel map is wrong?
I mean, that's the only thing we changed.
That is the only change we made.
The good thing is, as soon as you crank it up, there's water pouring out of the temporary tube from the bypass.
Oh.
So that is working. Okay. And it's coming out the regular port. So I know it's going through the engine and it's also bypassing. So we need to keep an eye on the water pressure as well.
I mean, dude, is it possible that that elbow flows so much more air that all of a sudden now our motor's lean?
I don't think so.
I would McFarland Tuning and Fabrication in the house.
This could get real. Oh, this is on V5, right?
Yeah. Oh, did you open V6?
No, I used the one that was open, but sometimes you got to reopen V5, so I'm not surprised.
Everything looks good back.
That's the kind of insight you get from McFarland tuning and tubing.
Where it's at. All right, here we go. Download ECU data log.
When you download the logs, is it the one at the very bottom or the one at the very top?
It's always on the bottom, yeah.
One at the bottom, all right. This computer smart's happening right there.
All right, so it made... £10, 11 pounds, 12, 14, 15. Right at 16 pounds.
At the hit? Wow.
Yeah, you're already at 16 pounds.
Holy cow, dude.
And then it went.
Was it lean?
No, in fact, it was pretty rich.
I wonder if there's a boost cut table somewhere.
I'll look at it.
That's weird. It's all of a sudden, like it's never ever done that.
Well, and it's never made boost that fast.
Oh, wow.
Yeah, there's the boost cut.
Might be that.
Now there's 0 boost cuts in right here.
Fisherman. It's all right. You enjoy that water while we're here tuning. After that, it's ours.
Stay out of this area.
I mean, up to the point where it lost ignition, it was like beautiful. So I don't know.
Ooh, are there any error messages We had a
like
problem.
RPM.
We had a problem once where it lost the crank signal.
That's what it sounded like to me. But
in the middle of a run, it lost the crank signal.
Yeah, it did. It aired out the crank signal.
It says it?
Yeah.
It did it again. Twice. Oh, that's weird.
This is actually part of what it's like to hang out with me. Because I have this problem a lot.
Do you? So it did it one time, the very first time I tested the boat during one pass. In the middle of the run, it just shut off.
You know what? I've had this problem too, and I've gone around and just like warmed up the engine a little bit more, and then it doesn't do it. So it's like, it's a total toss-up.
Let's go put some more heat in it. Can you look at the water pressure real quick and tell us what the water pressure is? I'm just trying to figure out.
Yeah.
Let's see if this works.
Which pressure, like, what's the sensor?
It'll say H2O pressure.
Yeah, so guys, it looks like it lost crank position sensor.
So a buddy of mine who tunes stuff says that with aftermarket blocks, you kind of have to grind down the boss so that the sensor bolts in further. Otherwise, it can lose crank sense.
A little bit too big of a gap.
Too big of a gap.
Not exciting.
Do you have water temp on there by chance on your main gauges?
He does. I don't.
So you can't see that.
Right now, the only thing that's working on here is GPS and RPM and TPS. Everything else is wrong.
Okay, well, I hate crank position sensors. They're literally the worst. Put a MSD wheel on the front, all good? Yeah.
And the downside of the crank signal going in something like this is if you're going fast, the motor shuts off. That's not fun.
Then you have no steering.
Never done this.
We got a data log, so we'll look again. Okay, the noise of the air coming through the turbos is so strange.
Can you hear them well in Leroy? Because there's no good.
No, because they're like...
Okay. Mission's back on.
I just want to make sure I went the right way on the valve. I'm trying to look. I looked up that exact valve. I just want to double check.
Oh, I was like, either peeing or trying to set up a
No,
drum.
I'm in the shade trying to look at stuff. And I can't. I just want to make sure you don't go out there and put too much PSI to it.
Yeah, it's definitely your crank.
Same thing.
Like, look, it just says, like, whatever, 51, 53, 54, 57, 59, air. 2222 air.
And that's crank position sensor.
Yeah, that's it's RPM. It could be a cam sensor, I guess, but it's definitely the crank sensor.
Damn.
I would think. It makes no sense why it would work the other day and then not today.
Yeah, it's like
blows me.
literally.
Flawlessly. It's only done it one time you're out there. Now it's doing it 3 times today.
This is such an LS thing to deal with. Well, Rick. So this is what happens. You hang out with me, you start having crank sensor issues. It's like my thing.
Thanks for bringing it to Georgia.
For the record, I didn't touch the laptop until it had the issue. Just want to put it out there in the universe.
You talked about it though.
I didn't say anything about crank sensors.
No, you said let's break out the laptop. Let's tune on it.
Yeah, that was me. I wanted it to go real fast.
I blame our new elbow. It's got to be it.
It's the airflow throwing off the crank sensor.
I listened to the internet, and now it has so much airflow that we got
so much more airflow.
all the boosts, all the PSIs, all the shh, and now it doesn't want to run.
Way to go, internet.
Yeah, thanks keyboard. Thank you. back to the house.
Brother, don't go. I wanted to tell him about our Lord and Savior that last day.
He's right there. He's still there. He's hanging out.
So here are our big upgrades in the quest for getting rid of our crank sensor issue and also finding out how much hot air is coming out of our turbochargers. This is a new air temperature sensor that we got from Hyperactive. This is the crank position sensor I just unbolted from our LSX block. And as you can see, it's made in China. Not saying that's why it broke, but it's unfortunate. The dudes from Texas Speed just sent me a genuine GM, also made in China, crank position sensor. I don't know. I don't know that the sensor is bad or not, but we'll change it. But we're also going to measure the distance from the reluctor wheel on the crankshaft to the tip of the sensor here and see if we've got a bigger gap than we need. All right. Intake manifold. Valve cover, exhaust manifold. We are on the passenger side of the engine. And if we come down in here and zoom past the spark plug wires, you will see inside of our LSX block a couple of teeth there. Those are the teeth of the reluctor wheel. It is welded onto the crankshaft. And I've heard a couple conflicting things. I've heard that on aftermarket blocks like the LSX, the mounting boss might be too thick and this might be too far away. I've also heard that that's only an issue with Dart engine blocks. So I honestly don't know, but we're going to measure anyway. So what we'll do is we'll grab a dial caliper and use the stick end of it to measure from the mounting surface to the tooth, and then we'll measure the sensor and see what kind of gap there is there. If the gap is excessive, we'll address it. If it's not, we're just going to change the sensor and see if maybe we just have a bad sensor. Because I think our wiring is just fine. Here's the plug. I don't really see any issues going on there. You know, it seems like that's happy. All right, couldn't get my dial caliper in there. And I didn't have anything else but a ruler here. And this is probably not the most accurate way to do this, but what I did was I shoved this ruler into the block until it hit the reluctor wheel, and then I grabbed a fine tip Sharpie and marked the ruler right at the edge of the engine block. And as you can see, there's not much of a gap there. Obviously, you know, there's some wiggle room, some air and all that, but it's pretty close. So I don't know that we've got an issue with distance there. Maybe the sensor just went bad. I was examining the new sensor versus the old one. The retaining tabs are at different heights, and the part where the retaining tab is held into this thing is at a different height. But the distance from the flange where it mates with the block to the end of the sensor is virtually the same. So I don't think we're making any significant change there in terms of the design, but maybe, I don't know, they changed the design of this, or it's a different supplier, or I don't know what, but these are slightly different. Like if you look at them from overhead, here's a better view of it. Like if you use the ruler to kind of get these things. See, if you put the bracket on the same plane, the tip of the sensor is nowhere near the same. But if we put, yeah, this is hard to do with one hand. If we put the sensor on the same plane, there we go. Then you can kind of see how the retaining tab is in a different spot. But again, the distance from the end of the sensor to where it contacts the block there, it looks like it's virtually the same. Interesting. And changing this is no big deal in a boat. It's not too awful in a car, except you do have to remove the starter, but in a boat, you know, you're just gonna plug this in and then put the bolt into it. Easy peasy. And there we go. New sensor bolted in place, wired back up. Hopefully that solves that issue. And right now I'm gonna weld a bung into our charge tube so we can put our new air temp sensor in it, and then we're gonna go back out and run this thing.
That's weird. We just set a new record. It just went 117, and while I was slowing down, the engine shut off. Weird. All right, let's go back. Man.
Damn. He went a long way. I wonder if that was intentional. I can't even see him. Well, I will tell you this, it sounded and looked awesome.
That is not the same boat. It just went 117 when I let off.
What?
And it got there way quicker. And I need to pull the data, but it sounded like it turned more RPM. Like, dude, like that 111 pass we made, you know, a couple months ago, I was in it for like half a mile when it did it. This was like, no, we're gone and we're there. And maybe that elbow was a huge restriction, dude. This is not the same boat. However, I blew the pop off and I was slowing down, you know, really slow, and the motor shut off again. So I don't know what that is. You know, we need to look at that. Obviously, it was okay because I'm slowing down when it turned off. I wasn't wide open, but the engine turning off thing concerns me. But dude,
it was awesome.
It sounded and pulled so much harder.
Yeah, you can tell. Like, you can tell right away when it left. You can just hear it, man.
Left hard too.
Yeah.
Okay, we're back in the garage. Let's recap what just happened. Pretty amazing turn of events. We made 2 changes, which we've talked about a whole bunch. We made a new elbow, bigger in diameter, and we also replumbed the cooling system to the engine and the intercooler for like the 5th time. And that I don't think had as much of an effect as the elbow did. And here's some numbers for you guys. The last time we went out, that boat went 111 miles an hour. The engine was only turning 5,771 RPM. This time we went out, the engine turned 6,043 RPM. And here's the differences, and here's, I think, what happened. When we started a run out before, with the old elbow, and we only went 111 miles an hour, we would begin the run with 154 degrees of coolant temp. By the end of the run, it would cool off to 150. We would begin the run at 116 degrees of air inlet temp, but it would climb. We would end the run at 173 degrees of air inlet temp. Now, to go 111 miles an hour, I stayed in the gas 4 seconds longer than I did to go 117. And here's the change. Here's what happened, right? We began our 117 mile an hour run with only 92 degrees of air inlet temp, and it only rose to 136. So we dropped nearly 40 degrees of air inlet temp this time around. We began the run at 140 degrees of coolant temp, and it dropped to 136 degrees at the end of the run. And again, the 117 mile an hour run, I was in the throttle 4 seconds less than I was the 111 mile an hour run. Also, the 117 mile an hour run, we had 1 degree less timing because we were higher up in the RPM band. All of this I know because we're running a Holley Dominator ECU that data logs every sensor in the boat at all times that it's active. And so you can see right here, give you a little visual, the dotted line up top is engine RPM. The engine RPM is over 300 RPM higher than it was the solid line, which was our 111 mile an hour run. You come down here, green, that's coolant temp. The dotted line, 117 mile an hour run. And the solid line, 111 mile an hour run. Same thing down here. This is air inlet temp. Dotted line, 117 mile an hour. Solid line, 111. Basically, the colder we can make the air going into the engine, the more power it's going to make. And the great thing about a jet boat is it works like an engine dyno. That jet drive will absorb every ounce of horsepower the engine is creating. And so the more RPM you're turning at speed, the more power the engine is making. And this is a substantial gain. And really, I think it came from the elbow. I don't think it really came from the water temp in the motor, because you're only talking about a 9-degree change in water temp, but you're talking a nearly 40-degree change in air inlet temp, which is huge. So huge gains. And now we can turn the boost up. I'm comfortable doing that now. This is with 20 pounds of boost at about 16.5 degrees of timing. So very little ignition timing advance in this motor. It's super safe. The spark plugs look great. There's way more left on the table. They tell me those turbos are good for about 25 pounds of boost, maybe 30. So we're getting close there. But we'll test it again later. Just not right now, because if Dave turns the camera, we need to build Blasphemy for Drag Week. And we're missing things. But we're going to make it.